I'm Simon Brown. I'm a professor of physics. My interests are in nanotechnology, particularly in how do you make small electronic devices, but also in understanding the fundamental physics of what goes on at a quantum mechanical level in those devices. So my research has two main themes. One of them is using scanning tunneling microscopy. So that's the instrument here behind me. Scanning tunneling microscopes are essentially a very sharp needle that you can scan over the surface of a sample and then use the image that's created by tracking the position of the needle so that you can essentially generate atomic resolution images of what's going on the surface. The other aspect of what we do is to make nanoparticles, really small particles, usually of metals or semiconductors, and then deposit them onto semiconductor chips between electrical contacts so that we can make a small electronic device. Those devices can have a range of functions. They can be sensors for gases, they can detect biological species, or they can be used, for example, as high-tech switches, possible new types of transistor that might go into a future generation of microelectronics. So the main reason it's interesting is that these experiments allow us to explore the fundamental quantum mechanics of what's going on in nanoscale objects. So for example, recently we discovered that the sizes of tiny metal particles can be controlled by the wavelengths of the electrons inside them. It's actually the first time anybody's been able to see this effect. The size of our little metal nano structures are governed by the wavelengths of the electrons, and so you're using fundamental quantum mechanics to control the sizes of the objects and hence the properties of the devices that you would make out of them. I think I've had a fairly typical career path for an academic. I started off as an undergraduate at Victoria University in Wellington. I went to Cambridge on a scholarship for my PhD. Then I did a postdoc, or a series of postdocs in Sydney, and also a short time in Vancouver in Canada. And then I got a job here at Canterbury about 15 years ago, now I'm a professor, but started off as a lecturer, and as is the normal thing, you work your way up the ranks. So one of my other interests is in New Zealand's prosperity, if you want to see it that way. A good friend of mine, Sean Hendy, up in Wellington, just written a book called Get Off the Grass, which is all about how New Zealand can catch up with Australia in terms of its productivity or in terms of its GDP per capita. And I'm really interested in these questions of what is the science that New Zealand needs to do to improve its technological capability and hence the productivity of its industry. I think it's a really important question because if New Zealand isn't able to do those things, our destiny is to be a poor country where it's much more attractive for our young people to go and live in Australia than it is to live here, simply because they can get better, more interesting jobs and get paid more. So I think it's really important for New Zealand to be able to address those problems. So the small white ceramic disc that you can see in the middle of the image, that's the core of the scanning tunneling microscope. There's a small needle mounted facing upwards on that disc.